So now what is the synthesis pathways of these various hormones? Let's start with adrenal cortex hormones and then move into adrenal medulla hormones. So in terms of the cortex, if we sliced the adrenal gland right in half, if we look through the various layers of the adrenal gland, we start with the capsule. The capsule is a fibrous layer and it's mainly connective tissue. Where we become most important with our hormone synthesis part is in the topmost layer, the zona glomerulosa. Here is where aldosterone is synthesized. Aldosterone is known as a mineralocorticoid. In this case, mineralocorticoid is because it is involved with sodium retention, which is one of our minerals. Below this level, we have the zona fasciculata. The zona fasciculata is involved with cortisol production. This is known as a glucocorticoid. You may be wondering yourself, what is this corticoid portion? That is to tell you that it's part of a steroid hormone base. In this case, it was initially named glucocorticoid because it's involved with glucose metabolism. Cortisol, though, is often known as a stress hormone. It's released in times of stress, and we'll go through all the different functions that it has. We also have the zona reticularis. This is where the androgens are produced. Where the androgens are, these will be things like DHEA and androstenedione. These will be involved with secondary sex characteristics. Finally, if we go to our lowermost level, this is now no longer in the cortex, is the adrenal medulla. And remember, the adrenal medulla is where epinephrine is released. Now, when we talk through the synthesis pathways for adrenal steroid hormones, the biggest picture that you need to remember is you start off with cholesterol. Cholesterol is the backbone of all three of these cortex hormones. What starts the process down the stairs? ACTH. This factor released from the anterior pituitary engages an enzyme called a side-cleaving enzyme that starts cholesterol down a number of stepped process to eventually reach its end hormone state. Now, we will include these steps along the way in the download material so you can look at them, but those are biochemistry related steps, and they're more important in biochemistry than in physiology. In physiology, we're concerned with the functions that happen in these processes. We will mention one other item, and that is for aldosterone. Aldosterone has a second regulatory step, and that's that aldosterone synthase that's affected by angiotensin II and potassium. The adrenal medulla also has a number of steps in its synthesis. But for pathology purposes, we need to go through all these steps because they occur in different locales within the adrenal medulla. You start off with amino acids such as tyrosine. Tyrosine then gets converted into L-DOPA. L-DOPA gets converted into dopamine. Then dopamine is transported into a chromaffin granule. Once inside the chromaffin granule, it is converted to norepinephrine. And then interestingly, it's moved back out into the cytosol again. And you may ask yourself, well, that's an odd process, but it's where the enzyme was located to convert dopamine into norepinephrine. Once you have norepinephrine out in the cytosol, you use an enzyme to convert it into epinephrine. Now it is in epinephrine is the form in which we're going to release it in the highest quantity. That's moved back in to the chromaffin granule. Then it is bound in a storage complex that has primarily epinephrine, about 80%, but a little bit of norepinephrine, 20%. That is how this process works to be able to do these conversions in the right spot, make sure they get in the storage granule, so then it can eventually dock and release and spill its contents out to be picked up by the blood and delivered to peripheral tissues. There are some transporters that are involved in this process. These are known as VMAT transporters. Oddly, the VMAT transporters are fairly similar between the different types of moving either dopamine in, norepinephrine out, and epinephrine back in again. That is because these three molecules, dopamine, norepinephrine, and epinephrine, are very similar in structure.